Okay, here's problem 6847. Make it bigger. All right. So notice that for the first inequality, the line associated with the first inequality, 2x plus 3y greater than or equal to 14. I can plot one intercept. When y is 0, x is 7. But for the other intercept, I got to plot a point other than an intercept. So if I let y be 4, then x is 1. That'll give me 2 plus 12 is 14. So to plot that first line, we said when y is 0, x is 7. And when y is 4, x is 1. So there's the first line. Notice that if I put in 0, 0 for the test, it points up above the yellow line, so I'm away. By the way, I didn't do the vertical and horizontal, so x is equal to 2 is another line. The vertical line, x equals 2, and the horizontal line, y equals 2. So we're up in this region up here with the square with the corner cut out. It's the square minus the triangle. Now the second line, I can do intercepts for both. When x is 0, y is 10. And when y is 0, I got 6x equals 30, so x equals 5. So there's my intercepts. So it looks like everything goes through that point there. And once again, if I put in 0, 0 for the yellow line, I'm above that line. Nope, it's less than. So I'm let's see, which line did I just draw? Oh, I highlighted it. For this yellow line, that's the second one I drew. If I put in 0, 0, I get true. So we're in this little rectangle because we're above the blue diagonal line, below the yellow diagonal line, and we're in the first quadrant to the right and above of the two horizontal vertical lines. So we're right in here. This is my feasible region. Okay. Now the corner points, the vertices. Starting here, it's 4, 2. And it satisfies all the equations. The first equation, you get 8 plus 6 is 14. In the second equation, you get 24 plus 6 is 30. And also y equals 2. Satisfies all three of those. Those are the three lines that go through this point right here. So that's where I'm going to start. So that's x equals 4, y equals 2. Comma, don't forget the comma between the points. The next point is up here. It's a lattice point. It's x equals 2, y equals 6. And the last one is not a lattice point. But I know x equals 2 because the vertical line and the bottom line, which is the first line that I drew. I'm sorry, it's the second line that I drew. No, that's right. It's the first one. My bad. 2x plus 3y equals 14. So I know x equals 2. So when I plug in x equals 2, I get 3y. I subtract the 4. 3y equals 10. So y equals 10 thirds when x equals 2. Now don't forget the fractions right there. 10 tab 3 tab parentheses. So there's my three corner points or vertices. Okay, and then the maximum. So now I got to use my calculator. Take the objective function 4.03 times x, got to turn it on. 4.03 times x, the first is 4, plus 2.05 times y is 2. So there's the profit for the first one. So then I hit second, enter, and now I change x to 2 and y to 6. There's the profit for the second point. Wow, pretty close. And then the last one. The 2 is okay. I got to change the 6 to a 10/3. So order of operations won't be violated. I don't need parentheses. So the maximum profit's $20.36. And that occurs at second point, 2.6. 2.6. And the minimum is the last one. To 2 decimal places, it's 1489.89. And that obviously occurs at the third point, which is 2, comma, I use the fraction symbol, 10, tab, 3, tab, parentheses. Okay, so we needed to plot points for the first equation, at least 1 point. We could get 1 intercept, but we can't get 2 because obviously 14/3, I can't graph that. So I got to use a point other than the y-intercept. I can find the x-intercept, but not the y. You can see over here on that first equation where I'm pointing on the graph, it's not a lattice point. It's between 4.5 and 5 on the y-axis, which is 14/3. Yep. Okay, so that's it for problem 6847. Dr. K, over and out.